Today, we're going to learn about the basics of chemistry. Chemistry in context, as far as what chemistry means in general. So chemistry is the study of matter, uh, properties, and the interactions of matter. We've been trying to understand this behavior of matter for more than 2,500 years. The Greeks originally thought that we just had four different elements of earth, air, fire, and water. And then much later on, we had what are called alchemists, where people tried to transform base metals into what were noble metals. So a lot of people in the medieval times would try to change metals into gold and silver, and they none of them had any luck doing so. But that was the chemistry, so to speak, at that time. Chemistry is connected to a lot of STEM disciplines. So if you are going to be studying medicine or agriculture, uh, or physics, mathematics, even computer science, um, chemistry is very much related to many other scientific fields and math fields. So we have some everyday life examples in chemistry. We might not think of it as chemistry, but it does happen in our day-to-day lives. For instance, when we're digesting food, if we are trying to make oil from turn it into gasoline, if we're trying to make clothing or plastics, those all involve chemistry. And of course, even just making medicine, and boiling water in your everyday life, and that still has to do with chemistry. So chemistry is a science based on observation and experimentation. So much like other sciences, we form a hypothesis and then we try to develop an explanation for those observations. The laws of science, they tell us a vast number of experimental observations, um, in order for us to predict things that are going to be happening in the natural world. A theory is a well substantiated, comprehensive, testable explanation of a particular aspect in nature. So theories are they are they've been checked many different times. That's why we say it's well substantiated, and it's also testable, which means that we can test it again to make sure that it's going to happen. And this is an overview of the scientific method. So you're going to see this in probably every science class that you take. You've probably seen it many times before in other science classes previously. So you have an observation, we make a hypothesis, we perform the experiment, and sometimes we have to make more observations because the results are not consistent with our prediction. So we have to form a new hypothesis again. But if they are consistent with our prediction, then it contributes to the body of knowledge of science. And after a lot of testing, it can yield a scientific law, or it can become a theory. So there are different domains in chemistry. There's the macroscopic domain, and other things that we can see. I think I mentioned boiling water earlier. The macroscopic domain is going to be like boiling water. We can see that water is boiling. We can we can we can feel that water is boiling, though you wouldn't want to do that, but you can see that very clearly. That's macroscopic. Microscopic is probably more of what we think of what chemistry is. It is everything that is visible through a microscope. It's I guess I should say only some of it is visible through a microscope, but it's all of the things that are very small, too small for us to see. And then also the symbolic domain, which we're very much going to focus on in chemistry, is the different symbols and the language that we use to represent the components of these chemical formulas. So moisture in the air, icebergs, and the ocean, they all tell us water. These are all water molecules, and they're in the macroscopic domain. So the water can exist as a gas in the clouds. It can exist as a solid in the ice, or it can be in liquid form. So that's all macroscopic domain. But at the molecular level, microscopic domain, we can start to describe what these particles look like. And that's these diagrams here. So the gas molecules are far apart in the microscopic domain. They're a little bit closer together. They're very much closer together in a solid, and then the liquid, they're free to move about, but they're still close together. So notice that in the solid, they're arranged in a specific pattern. So we're going to look at how formulas are arranged in specific patterns as well later on in this course. All right, so these are the practice assignments associated with this part of the lesson.